Welcome back to another one of my learning derivatives videos. This lesson will be focusing on the quotient rule, Leibniz's notation, as shown here, and we'll be deriving inverse trig functions. So, as usual with the quotient rule, you have a function which equals a function over another function, and when you derive this said function, you get the second function multiplied by the derivative of the first function minus the first function multiplied by the derivative of the second function all over the second function squared. Okay, now to save time, I've already written out most of the question, or the part that takes the longest anyway. So here we have the function y equals x squared over the inverse tangent of x. Now, do we have a function divided by a function, u over v, therefore we use the quotient rule. So u is coloured red, v is coloured blue. The derivative is v multiplied by the derivative of u minus u multiplied by the derivative of v all over v squared. And I've got it all down here, what we need to fill out in order to complete this. Therefore, we're going to call u x squared because it's on top, and we're going to call v negative inverse tangent of x. So u we'll say is x squared, and we'll say v is the inverse tangent of x. Okay, so the derivative of x squared is 2x, and the derivative of the inverse tangent of x is 1 over 1 plus x squared. Okay. So what we're going to do now is fill it out because we have all the info in order to complete this. So that's what we're going to do. We're going to complete it. So the derivative of y with respect to x equals v, which is the inverse tangent of x, multiplied by the derivative of u, which is 2x, minus u, which is x squared, multiplied by the derivative of v. The derivative of v is 1 over 1 plus x squared, all over v squared, which would be the inverse tangent of x squared. Okay, so now we have that. Let's do a bit of simplifying. Okay. So we'll bring the 2x out the front. 2x, 10, negative 1x minus x squared on 1 plus x squared all over 10 to the power of negative 2x. And why do I do that? Well, this is the same as having 10x to the power of negative 1. So when you have a power, when you have 10x to the power of negative 1, then again to another power of 2, you multiply the powers. And what you end up with is 10x to the power of negative 2. We just multiply the 2 to the negative 1. Okay? Now what I'm going to do is I'm going to split it. I'm going to have a 10x to the power of negative 2 on either side of the minus. So we have 2x, 10 negative 1x over 10 negative 2x minus x squared over 1 plus x squared over 10 and to the power of negative 2. Okay, that's what it's going to look like. Okay, so let's do a bit of eliminating to finish this off. So we're going to cancel one of these, and we're going to change this to a 1. And we're going to bring this bottom row, this little bit here, we're going to bring that on the bottom. Okay? Because we could, that's what you do for 1, but this whole bit here is on the bottom of this fraction. So we can bring it to the top of this fraction, and then we can bring it to the bottom of this fraction. We can bring it to the top of this fraction to make it a negative power, and then we can bring it to this bottom to make it a positive power. If that doesn't make sense, I've got previous videos on learning this topic which explain all of this. Okay, so what we'll have is x squared on x squared plus 1, 10, negative 2x. Okay, that there is the first derivative of 2x over the this is the of x squared over inverse tangent of x. Okay, that's the derivative. Okay, so let's go on to our second example. Y equals arc sine x over ln of x. This arc sine x is the exact same as before when we had tan to the negative 1. This is the same as sine to the negative 1. It's just written a different way. Okay? So we have a function over another function. We have u over v. We're going to label the top section as u and the bottom section as v. This is the formula for the derivative. I already read it out before. I don't need to do it again. So we need to find u. We said that u is the top, so it's going to be arc sine of x. And v we said was going to be ln of x. Now we need to find the derivatives of each one of these. So the derivative of arc sine x is 1 over the square root of 1 minus x squared, and the derivative of ln of x is just 1 over x. Okay, so now we have that, we can fill out the formula. So we have the derivative of y with respect to x equals v, which is ln of x, multiplied by the derivative of u, which is 1 over the square root of 1 minus x squared, minus u, which is arc sine x, multiplied by the derivative of v, which is 1 over x, all over the square root of v. I mean, the is v squared, not square root, so that would be ln of x squared. Okay, so now we have this written out. Now we've got something to work with. So what I'm going to do is I'm going to split this. So I'm going to have an ln of x squared on either side of the subtraction, or the minus sign. So I'll have ln of x multiplied by 1 on the square root of 1 minus x squared, all over ln of x squared, minus arc sine x multiplied by 1 on x, all over ln of x squared. Okay, so we can cancel 1 from the bottom and 1 from the top, and what we're left with, and because we have a fraction on top of a fraction on top of another fraction, we're going to bring the bottom of that fraction to the bottom of this fraction. So hopefully that's not too confusing. We just did it before, but we're going to have 1 over ln of x multiplied by the square root of 1 minus x squared. So what I did was I brought it out and then brought it under. Same thing, by the way, exact same thing. Okay, subtract. Now we're going to do that with this, because we can't eliminate anything here, but we can bring this 1 over x, we can bring that x to the bottom. Arc sine x all over ln squared of x multiplied by x. Okay, I just rewrote this ln of x squared as ln squared of x. It's another way of writing it, make it look neater. And this 1 over x, bringing it to the bottom, that's the exact same. I didn't do any sort of tricky stuff, I just brought it to the bottom. Okay? Now that there is the final derivative, that is your answer to the derivative of arc sine x on ln of x. Okay? Thanks for watching. I hope you enjoyed this video, and I hope you learned something. Thanks for watching.